Hi everyone. Today I'm excited to show you how we're using Kitware's VolView platform to bridge the gap between cutting-edge medical AI and clinical workflows. VolView is an open-source, web-based radiology viewer built on View. Its power isn't just in visualization, but in its extensibility. We've collaborated with NVIDIA to integrate their new Clara foundation models, demonstrating how to move AI from a research tool into a truly integrated assistant. Here's how it works. VolView is interacting with a distributed Python backend. You can see we're configured to connect to 3 different services. For this demo, our generate model is running on a powerful remote cluster, while my segment and reason models are running right here locally. This flexibility is critical for deployment. Let's start by generating new data. We're using the NVIDIA Clara generate model, and for each model, you'll see that we provide the NVIDIA model card. This is a best practice popularized by platforms like Monai to ensure transparency. It provides crucial details on the model's intended use, training data, or performance limitations, which can be essential for responsible AI. I'll now ask the model to create a synthetic, high-resolution 3D CT scan from scratch. This is incredibly useful for research and training scenarios where data may be scarce. And just like that, a new realistic 3D volume is generated from the cluster and loaded directly into our viewer. You can interact using all of VolView's image processing capabilities and then export or share the results. Now let's analyze it using another one of NVIDIA's open models. We'll move to the Segment tab, which uses the NVIDIA Clara segmentation model built on Vista 3D. Now I'm going to upload a separate, larger image and ask the AI to perform a full-body anatomical segmentation. The request is sent to our local Python server, which processes the entire 3D volume. And there we have it, a 3D segmentation associated with the volume in VolView. This isn't a static mask, but it's a composable object that's interactive with a clinician or researcher. I can further isolate specific organs and dive right into the data. Finally, let's talk to our AI assistant specialized in chest X-ray. I'm going to upload a simple chest X-ray and switch to a 2-dimensional view. This panel is powered by the NVIDIA Clara reasoning model, a multimodal chatbot that is context-aware of the image. I'll start with one of its suggested prompts. Now, for this model, the weights are cached locally after the first use. This allows for the immediate real-time feedback you want from an assistant. It analyzes the chest X-ray and gives me a text summary right in the panel. But let's try a custom follow-up. This model is trained on chest X-rays, so let's see how it handles a related question. I'll ask it if it sees any common findings related to pneumonia. As a smart assistant, it should recognize whether there is a match or mismatch and provide me with context that guides my understanding. And as you can see, it's able to answer my general medical question about the chest X-ray. This can provide invaluable feedback and understanding to a clinician or even non-clinicians as they gain an understanding of the case. So in just about 2 minutes, we've generated a synthetic CT scan, run a segmentation model, and had an interactive conversation with an AI assistant inside a web browser. This integration shows a new paradigm for medical AI. We invite you to check out the project on GitHub.